Okay guys, so this next two sections that we're going to talk about actually in this video is 8.2 and 8.3. And what we're going to learn in these two sections are basically shortcut methods on proving triangles are similar. In the last week we learned about proving triangles similar. In order to do that, we needed to prove that all of the angles were congruent and all of the sides were proportional. So that's a lot, right? That's a lot of things that we need to check to make sure two triangles are similar. So what we're learning here are shortcut methods to prove triangles are similar. And we've got three of them. We can prove triangles are similar by AA, side, side, SSS, side, 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 angle, 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 or side, angle, side, SAS. And so that's what we're going to talk about in this video. Let's jot down and read about those three different shortcut methods, the three different theorems. AA is our very first one. That's angle, angle. And it's like the short and sweet one. Look at this example. All we need to know is that two angles are congruent in the two triangles, and that's it. So look, we could say angle A and D are congruent, B and E are congruent, and then I could write the similarity statement that angle ABC is similar to angle DEF. That one's super nice. Okay. The next shortcut or theorem is side angle side, SAS. And I mean, guys, it's pretty much explains what you need in the title. I need to have an angle congruent in the two triangles. So here we can say angle X is congruent to angle M. And then the big thing with the sides is it can't be just any sides. It needs to be the sides including the angle. So it has to be the sides that form this angle. XZ has to be proportional to MP. See how they're corresponding and around the angle. And then XY has to be proportional to MN. See how they're corresponding and they form this angle. Okay, it doesn't have to be anything with this side. In fact, if it's something with that side, we can't prove that these triangles are similar. It has to be the sides including the angle. Okay, and then the last theorem is the side, 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 SSS theorem, and it's pretty much what it says, right? All three sides need to be proportional. So again, we've got to match up our sides. Short side needs to be proportional to the short side, medium side, long side, long side. Okay, and that's how we're going to match these up when we do some examples. Look for the short sides, medium, and the long sides. And that's for side, side, side. And then we can say the two triangles are similar. Okay, so we're going to check out lots of examples on this next page. The first two problems here are the two triangles similar? How do we know? So remember our three shortcut methods, AA, SAS, or SSS. Okay, if I look at problem A here, all I'm given are angles, right? So I will not be able to use these two shortcut methods, right? Hopefully, I'm going to be able to use AA. Okay, so if you look, I need to have two angles congruent. I have the right angles. Okay, so we're halfway there. I kind of use this as my checklist. If I know that this angle is 39, obviously we know we can find out this angle 180 minus 39 minus 90, and I get that angle is 51 degrees. Right away, then I realize I've got congruent angles. This angle is 51, this angle is 51, there's my other angle. Okay, so I could say yes, the triangles are similar by, we can explain, angle, angle. Okay, let's check out B. So when I look at B, I really know, again, I only know the angles. I know that these sides are congruent, and what that tells me is I've got an isosceles triangle. So if this angle is 68, I know that this angle is 68. So that kind of is helpful because then I can get that this angle is 44, but I don't know anything about the sides. So hopefully, again, I'll be able to use angle, angle. 68, 68, 44. Again, if this is 62, we can, and this tells me we've got an isosceles triangle, I can do 180 minus 62. That gives me 118. divide that in half, that gives me 59. This angle is 59, this angle is 59. None of those angles are congruent, so no, the triangles are not similar. Okay? Now we're going to do the same thing. Let's keep practicing. Okay, so problem 2. We need to figure out if the triangles are similar. If so, we need to write the similarity statement and then explain. Okay, so if I look at A, all I see are about 3 sides. So hopefully I'm going to be able to use side, side, side. That's how we narrow it down. That's the first step you want to do. Which shortcut could I potentially use? And there's really only going to be one. And now when I know, okay, I could probably use side, 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 I need to make sure my sides are proportional. So let's set up our proportion. Short sides to short sides. So I'm going to say 6 over 8 is proportional to 6 over 8. And then let's set it to 9 over 12. And when I reduce these, we need to hopefully get the same scale factor, which I do. So we can say yes, and here's our similarity statement. Triangle, if I start, let's start at if I start at C, where the 2 short sides are, and then go down, I'm going to get triangle CBA is similar to triangle GFE. Order matters. By, we have to explain, side, side, side. This is the sentence that's really important. Yes or no? Here's my similarity statement, and then explain. All right, let's check out B. So right away when I look at B, I see I'm given one angle, and then I'm given 2 sides, right? I don't know anything about these third sides, so hopefully that means I'm going to use side, angle, side. Well, angle A is in both triangles, so I can say angle A is congruent to angle A. That's cool. Then we've got to see if our sides are proportional. Okay, so I need to set up corresponding sides. So 8 here corresponds to this whole side of the bigger triangle, 16. 6 over here, that little triangle, corresponds to 12 of the bigger triangle. And we reduce these, amazing. So we can say yes, and I'm going to start with A and then go to the right. Triangle ALW is similar to triangle ACE by side, angle, side. Okay, we can write our similarity statement. Let's check out C. Okay, so C, again, let's look at what I'm given. I'm given an angle. These angles are congruent. That's cool. And 2 sides. So hopefully we'll use side, angle, side. We can say angle G is congruent to angle E. That we know right away. And then let's do short side to short side. And make sure that's proportional to long side and the long side. So then I've got 12 over 15, that's 4/5. And then 16 over 20, that's also 4/5, amazing. So we can say yes, and I'll start with that angle and go to the long side. Triangle GUA is similar to triangle, start with this one and go to the long, EFB by side, angle, side. Let's check out D. All I'm looking at when I see D are angles, no sides. I don't know anything about the sides. So hopefully I'll be able to use AA. And I've got 35 right here. I have vertical angles, so I know this angle is 35 too, which lets me find, obviously we know we can find Z, right? 180 minus 100 minus 35 gives me 45. And right then I realize I've got congruent angles, 45, 45, 35, 35. So we could say yes. Triangle E, I'll go to the 45ZA, is similar to triangle EBR by AAA. That sentence is really important. Good job, guys. One last one to look at. When I look at E, all I see are sides. So hopefully I'll be able to use side, side, side. And we want to set up a proportion for our sides. So remember the last one kind of went fast because we were only dealing with angles. Angles need to be congruent. Sides for similar triangles need to be proportional. So that's why these take a little bit more work because we have to set up these proportions, make sure we have a scale factor. So let's go ahead and do that. Short side to short side. I've got 2/3. Make sure that's equal to proportional to the next. Let's do medium, 3 over 4.5. And then I've got the long side, 4 over 6. Okay. As soon as I see this, guys, this 4.5, I want to get rid of this decimal because this is going to be hard to reduce. So if I just multiply this by 10, you can pick something that's easy for you to get rid of that decimal. Then I'm going to have, all that does is just make this a similar, equivalent fraction. So I've got 30 over 45 now. Same value. Okay, they're equivalent fractions. And then now let's reduce and see if I get the same scale factor. 2/3 equals, hey, 2/3 equals 2/3. So amazing, I can say yes. I'll start at the top here and go to along the longest. Triangle ACB is similar to triangle, start at the top and go to the longest, FDE by side, side, side. Okay? So first thing when you do these, guys, is you have to figure out which one you could potentially use, right? Figure out what information you're given and then assess that information. Angles have to be congruent, sides need to be proportional. All right, that is section 8283. Great work, guys. Awesome job.